Good day, students. My name is John Obodo. So today we want to look at the topic light waves. This is one of the major topics in physics. We are going to demystify the light waves. So in this class or in this lesson, we are going to learn to interpret the following terms: wave, light, optics, elementary wave, wavelength, frequency, period, speed of light, refractive index, and so on and so forth. We are going to describe the basic features or characteristics of light and state and apply the relationship between wavelength, frequency, and the speed of light. State and use typical values for the wavelength in a vacuum of light, and so on and so forth. We are going to look at the term coherent and incoherent sources of wave, rectilinear propagation of light. We're going to look at the concept and construction of plane mirrors and curved mirrors, application and uses. We'll also look at refraction of light through lenses and glass prisms. Also, in this topic, we are going to explain optical instruments and their applications and other related terms. Okay, so as we go along in the topic, we need to understand that light is more or less a form of energy. Light is a form of energy. It's a kind of radiant energy that causes the sensation of vision. So without light, you cannot see. Okay? Light is more or less a source of or a form of energy from the sun. Optics, on the other way around, is a branch of physics that deals with the properties and application of light, or properties and application of light waves. Okay, so light waves here, we are going to look at how different materials respond to light, how different materials respond to light, and what are the sources of light. Now look at the sources of light. We have two types or two major sources of light. We have what we call the natural source and the artificial source. Natural sources of light include the sun, the stars. We have fire, electricity in the storms. We have firefly, jellyfish, and mushroom. Some kind of mushroom produce light. Okay, so these are types of sources of light from natural sources. So for artificial light, these are the light created by humans, and you can get such from some from light from the candle. We can talk about light from some other sources that are artificial. We have the candles, we have some form of electricity, and so on and so forth. So light from the sun is a typical example of a natural source of light. Okay? The moon, on the other hand, have also light. But the light that is from the moon is a reflected light. It doesn't have its own light. The moon gets its own light from the sun. Okay, so and the light from the moon can be classified as natural because it's not man-made. And the light is gotten from the sun, and the sun shines it, and it is stored by the particles present in the moon. Then later on, maybe at night, the light is now shown to the part of the earth that is facing the moon at that point in time. Light and objects. Different objects respond to light in different forms. So based on that, we can classify object as opaque object. We talk about transparent object, and we also have translucent object. What is an opaque object? An opaque object is an object that do not allow the passage of light through it. Examples of opaque objects, we have stones, rocks, and non-transparent clothing. They are opaque in nature. They do not allow the passage of light through them. We have translucent objects. These are objects that can be seen through but not clearly. Some of these objects that allow such light to pass through, like wax paper, some kind of clothing, cotton clothes and all that, they are a bit transparent, not clearly, but they are partially, let's say they are partially transparent. So that is translucent object. We have transparent objects. Transparent objects like glass or glasses are objects that allow light to pass through them. Examples of transparent objects include glass. We have other objects like transparent nylons and so on and so forth. So these are the classification of light, or how light behaves to various objects. Okay, we look at the term rays and beam. Rays and beam. What is a ray of light? The term ray of light is the path or the direction of light path. That is, when light energy travels in a medium, the path it creates is called the ray. A single ray of light can be represented as shown. Okay, this is a single ray of light. But in most cases, light travels in beam form. Like the light we see around our environment, most of them come in the form of beam. And when you talk about a beam of light, this is a group of light rays traveling in the same direction. The group of light rays traveling in the same direction. There are different types of beams of light. Different types. We have what we call the convergent beam. The convergent beam. We have the parallel beam. Parallel beam. We have the divergent beam. Divergent beam. Okay, so convergent beam, we have something like this. This is a point, and different rays of light converging at that particular point. This is a point P. So when rays of light converge towards a point, we call it convergent beam. But when the rays of light are parallel to each other, such that they do not intersect, even at infinity, you call them parallel beam. So this is an example of parallel beam of light. And for divergent beam, we talk about rays of light that spread from a point. From a point, they spread to different corners, such as this. So we have a convergent beam, we have parallel beam, and we call this one 1, 2, and 3. So this one is 1. That is for convergent beam. 2, that is for parallel beam. And 3 is for divergent beam. So the three types of beams have different application. And well, as we go on, we are going to see how they are applied in various areas. So let's look at the concept of, okay, that is a ray of light, parallel beam, convergent beam, and so on and so forth. We also have a diagram showing the spreading of light from a point around different corners. So that is for that. So we'll move on to the term, rectilinear propagation of light. What is rectilinear propagation of light? This is the ability of light to travel in a straight line. When light travels from one point to another in a straight line, you call it rectilinear propagation of light. A simple analysis of this is when we make holes, something like a pinhole in different cardboards, maybe several cardboards along a straight path, and light up a candle at one end, and through the slitted holes or pinholes, we can look through the holes and see the candle light, just as shown in the diagram. So what we have here, we have a candle, we have the cardboard, 3 cardboard A, B, C, such that they are arranged in a straight line, and the human eye seeing the candle from those pinholes. So that describes what we call rectilinear propagation of light. Rectilinear propagation of light is important in analyzing how light can travel from one point to another, especially light that is coming from the sun. The light from the sun travels several thousand or million miles before it gets to the earth. And therefore, for light to travel in a straight line, we describe the concept of rectilinear propagation of light. There are effects of light traveling in a straight line. And some of the effects will be looked into. And one of them is what we call eclipse. And the second one is what we call formation of images. Without the rectilinear propagation of light, we don't have this kind of effect, such as eclipse and image formation. Okay? Eclipse is more or less a transit, an astronomical event where a celestial body partially or totally covers another celestial body. Okay, that is for eclipse. So we have 2 major types of eclipse. What we call the solar eclipse and the lunar eclipse. the solar eclipse and the lunar eclipse. When the sun is obstructed, the light coming from the sun is obstructed from getting to the earth. As a result of that, part of the earth is in darkness. We call that solar eclipse. The moon is opaque. It doesn't allow light to pass through. So it blocks the path of light, and what we see is that part of the earth that light is supposed to get to will be in darkness. We have a diagram there that describes the eclipse of the sun. Okay, it is an occasion when the moon is between the earth and the sun, like I mentioned earlier. So you see the moon coming between the sun and the earth. Very important diagram. Let me just quickly describe the diagram that we can use to describe the solar eclipse. Solar eclipse using a ray diagram. We have the sun represented here, and we have the earth represented here, and we have light coming from the earth, the sun. There's the sun. Light coming from the sun. Then the moon is located at this point. Let's say this moon is blocking the path. That's the moon. The moon within the region of the Earth's atmosphere blocks the path of light coming from the sun. So as a result of that, this portion of the Earth will be experiencing darkness, or what we call eclipse. So that results to what we call eclipse. That means the part of the earth is eclipsed into darkness. So but other part of the earth may be experiencing light and all that. So this describes the solar eclipse, or what you may refer to as eclipse of the sun by the earth. That means the moon comes between the sun and the earth. So that is a typical example of eclipse. So we have the second type of eclipse where the earth comes between the sun and the moon. In such eclipse, we call it the lunar eclipse. In this case, the earth blocks the light that is going to get to the moon. As a result of that, the moon is found to be in complete darkness. And in such cases, you see the moon disappears from the sky. And if you look at the sky, you will not see the moon. And that is as a result of the moon hiding behind the earth. With that, we can call it a lunar eclipse. So we can say that a lunar eclipse occurs when the moon moves into the earth's shadow. This can occur only when the sun, earth, and moon are exactly on a very close line. That means they must be on a straight line. That means the light coming from the sun cannot get to the moon. We can say that the moon will be in complete darkness. We can describe a simple diagram for what we call the lunar eclipse. Lunar eclipse. We have the sun once again, and the earth. We have the earth, then the moon. We have the moon here, and the earth here, and we have the sun. The radiation coming from the sun is found to be blocked or obstructed by the earth because the earth is opaque. It doesn't allow light to pass through. So as a result of that, the shadow will be casted and there will be darkness around this region. That means the moon will be in total darkness. So in this case, we talk about the lunar eclipse. That means we are saying that the earth will come between the sun and the moon. That is the eclipse of the sun by the earth. The earth blocks the light that was supposed to get to the moon. Okay, so that is for the lunar eclipse. So apart from those two effects of eclipse, we're talking about eclipse, solar and lunar eclipse, we also look at what we consider as the ancient form of camera. The cameras that were used even while modern technology have not been in existence. What we call the pinhole camera. The pinhole camera is a simple camera without a lens, but with a tiny aperture. It is effectively a light-proof box with a small hole in one side. Okay? light from a scene passes through the aperture and projects an inverted image on the opposite side of the box, which is known as the camera obscura effect. We call it camera obscura effect because the image form is always inverted. Okay, just like the eye, when we discuss how the eye functions in such a way that the image formed on the retina is inverted. But when the brain wants to interpret the image, it will make it to stand in the proper order. But actually, the image formed on the retina of the human eye is always inverted. But it is the brain that reverts it back to a normal form. So just like what we have, the pinhole camera, I have a box, we have a small hole, and the object placed in front of it, then the image formed by the pinhole camera is always inverted. The image form is always what? Inverted, and is also, we can say it is diminished. It is diminished, and it is real. Why is it real? Because it is formed on a screen. That have to do with formation of images, which we are going to discuss in subsequent classes, talking about mirrors and maybe including plane mirrors, curved mirrors, and other forms of mirrors, and also lens. We look at image formation in those optical instruments. So that is for pinhole camera. So at this point, we talk about the properties of light. The following are the properties of light. We have what we call effect of light, materials on light, which we have discussed. We also talk about reflection of light, how light is reflected by different surfaces. We also look at refraction of light and dispersion of light. We'll consider also what is known as total internal reflection of light, interference of light. How is light interfered? Or how does light interfere with other forms or sources of light? Also, we look at diffraction of light. Light can be diffracted, just like waves. Waves can be diffracted, so light can also be diffracted because light is a wave. And we also look at scattering of white light. When light is scattered around, what happens? Then, under the properties of light, we will not forget to discuss what we call polarization of light, because light is a transverse wave. We are going to conclude this light lessons with the concept of polarization of light. We look at it from the wave point of view. And when we consider it from that point, we say, okay, how is light polarized? So at this point, I will enjoin us to look up to the next class as we continue with the properties of light and how light behaves in certain material. We're going to start with what we call reflection of light in plane mirror and curved mirrors, and how images are formed in those mirrors. So as we continue with this, I want you to sit down, relax, and enjoy the class. Thank you for listening.